Hi everyone, this video will introduce you to hypotheses. Hypotheses are testable statements or predictions made by the researchers about the relationship between variables. We will cover the following topics in this video. How do we start and end a research process? What types of hypotheses you need to pose when testing a claim? We'll cover the variables and attributes of variables in our hypotheses. We'll create a fictional hypothesis of a relationship between crime and immigration. We'll briefly mention the units of analysis as well as the reference probability and error types for testing the hypotheses. In the end, I will show you how to test a hypothesis using SPSS statistical software. Let's quickly summarize the research process through a circular diagram. In the beginning, you start with an interest, a theory, or an idea for which you wish to find out more. In research design courses, we may call the theory a research question. Through the process of deduction, you develop testable hypotheses. After posing hypotheses, you decide on a design and methods for research. There are a variety of methods available for research with their own strengths and weaknesses. Designs can be a true experiment, survey, field research, content analysis, etc. Then you decide on a method for data gathering or sampling. Where would you get the data? Depending on the research method, you'd collect data yourself, access data collected by others, or a combination of both. The next step would be the analysis through statistics and probability and a variety of statistical tests such as t-tests, ANOVA, chi-square, correlation, and regression. I'm sure you've heard about them. Then you conclude and report whether the hypothesis is correct or not, and through the process of induction, validate or not the theory you started with. Let's cover other concepts, such as hypotheses and variables, which are extremely important in statistical analysis. Hypotheses are specific statements about the relationship between two or more variables and are derived from more general theories. They demonstrate an educated guess about the relationship or differences between variables in scientific research. There are three types of hypotheses: research hypotheses, null hypotheses, and alternative hypotheses. A research hypothesis states an expected relationship between variables in positive terms. An example would be the relationship between homelessness and crime. In the form of a research question, this would be stated as, are homelessness and crime related? In the form of a research hypothesis, you would state it as, I predict that homelessness and crime are related. The null hypothesis is a hypothesis of no difference or no relationship and is the one actually tested statistically. For example, homelessness is not related to crime. Null means no effect or nothing, so it basically states that there is nothing happening between the variables. Do not confuse the null hypothesis to mean that the statement is null itself, meaning that it amounts to nothing. I guess if the term was nullifiable hypothesis, that might have caused less confusion. However, it is called null hypothesis. I think many of you might ask, why do we need this null hypothesis and what purpose does it serve? The null is an abstract, is a fictitious concept. It's our creation. What we want to know is what human nature wants to know, the difference between people or things, or whether there is a respective relationship there. So why do we create a fictional concept such as the null, which all it does is that it states that there is no difference, the opposite of what we want to know. We create this null hypothesis as a workaround to get answers about what we want to know, which we cannot get or test right away. So we create the null and test it in hopes that we reject it, because it is easier to reject the null than to find out that the research question is true. It is easier to test the null because out of all possibilities, there is only one where things are equal, where nothing is happening in this reality, and an infinity where they are different. There is only one possibility that there is no relationship at all at point zero, but an infinity between -1 and 1. And if we reject the null, it automatically means that we reject the no relationship or no difference proposition. So we accept the opposite idea that there is something happening here which we wanted to prove in the first place. The null hypothesis we used as an example before would be that homelessness is unrelated to crime, or, stated otherwise, there is no relationship between homelessness and crime. The alternative hypothesis is the hypothesis that is the opposite of null, and it is the statement that matches your research question, what you want your study to show. The alternative should complement the null, so both the null and the alternative should make up 100% of all possibilities out there. So if the null is that the new car's gas efficiency, mean miles per gallon, is 38, the alternative should be that the mean is not 38 miles per gallon. It does not matter if it's more or less. However, sometimes alternative hypotheses can be stated as directional or one-tailed. In this example, we can state that the mean is less than 38 miles per gallon. However, this does not capture the universe of possibilities where the mean miles per gallon would be greater than 38. It is advisable, however, that most of the time you should state two-tailed hypotheses. There could be a complete semester needed to explain only hypotheses. Let's talk about variables. As we mentioned before, variables are concepts that have been operationalized. A variable, then, is an entity that can take on different values. Okay, so what does that mean? Anything that can vary can be considered a variable. If something is able to vary, it is a variable or variable. For instance, age can be considered a variable because age can take different values for different people or for the same person at different times. Similarly, country can be considered a variable because a person's country can be assigned a value. Theoretically, variables can be of a qualitative nature. For example, qualitative distinction could be made regarding a person's age, old or young. The variable borough can consist of different values, such as Brooklyn, Manhattan, or the Bronx. But we can, if it is useful, assign quantitative values instead of the text values. But remember that we don't have to assign numbers in order for something to be a variable. An attribute or category is a specific value on a variable. For instance, the variable agreement might be defined as having 5 attributes. 1. Strongly disagree. 2. Disagree. 3. Neutral. 4. Agree. 5. Strongly agree. Or New York City's boroughs attributes, as we mentioned before, are Brooklyn, Manhattan, the Bronx, Queens, and Staten Island. Counties attributes may be different. Finally, there are 2 traits of variables that should always be achieved. Each variable should be exhaustive. It should include all possible answerable responses. For instance, if the variable is religion and the only options are Protestant, Jewish, or Muslim, there are quite a few other religions I can think of that have not been included. The list doesn't exhaust all possibilities. On the other hand, if you exhaust all the possibilities with some variables, religion being included, you would simply have too many responses. The way to deal with this is to explicitly list the most common attributes and then use a general category like other to account for all remaining ones. In addition to being exhaustive, the attributes of a variable should be mutually exclusive. No respondent should be able to have 2 attributes simultaneously. Generally, this is easy, but while this might seem obvious, it is often rather tricky in practice. Variables may be measured on 4 levels: nominal, ordinal, interval, and ratio. Nominal and ordinal variables are usually called categorical variables, while interval and ratio are numerical variables. For detailed information on levels of measurements, please watch a video I have put on YouTube on this very topic. Now let's look at the predictor and outcome variable, more typically known as independent and dependent variables. Another important distinction having to do with the term variable is the distinction between an independent and dependent variable. This distinction is particularly relevant when you are investigating cause and effect relationships. We must learn this distinction. let's start explaining the dependent variable, the outcome. This is the variable one is attempting to predict. By convention, it is represented by the letter Y. Common dependent variables in criminal justice are concepts such as crime, arrest, recidivism, etc. The independent variable, the predictor, is the variable that causes, determines, or precedes in time the dependent variable and is usually denoted by the letter X. An independent variable in one study could become a dependent variable in another. For example, a study of the impact of homelessness X upon crime Y finds homelessness as the independent variable, whereas a study that looks at poverty as a predictor for homelessness finds homelessness as a dependent variable Y. As a rule of thumb, the treatment variable is always an independent variable or predictor, as are demographic variables such as age, sex, and race. The dependent variable usually is a behavior or an attitude. We'll explain hypotheses and variables with an example. Let's say that we are interested in immigration status and the number of offenses committed in general by non-citizens. So the research question is the statement that there is a relationship between immigration status and the number of crimes committed. Although for purposes of this podcast, this hypothesis is fictitious, this would be an excellent topic for a research. Finding out if lawful residence and higher status of immigration culminating with U.S. citizenship decreases crime, it would be prudent to recommend policy encouraging naturalization and/or lawful immigration. The null hypothesis is a statement that generally states that there is no relationship, no association, or no difference in the observed relationship. This is the hypothesis that we test using statistics and probability. In relation to our research question, the null hypothesis, denoted as H0, is there is no difference in the number of offenses committed by individuals in different immigration statuses in New York City. Although we talk about the relationship between two concepts or two variables, in this case, technically, we are testing the difference in the number of crimes committed by participants in each of the categories of immigration status. The alternative hypothesis is the opposite of the null and generally states that there is a relationship, an association, or a difference in the observed relationship. This means that if the relationship was observed, it may be positive or negative between the variables. This is called a two-tailed alternative hypothesis because we want to know the full extent of the relationship, not just one direction. Here, I present a two-tailed and one-tailed alternative hypothesis. The two-tailed, HA or H1, is that there is a difference in the number of offenses committed between different immigration statuses. The one-tailed alternative hypothesis would be the higher the immigration status, including U.S. citizen, the fewer the number of offenses committed. This hypothesis has two variables, immigration status and number of crimes committed. Immigration status is a categorical variable because it contains categorical attributes such as lawful permanent residents, also known as LPR or green card holder, refugees, workers, and naturalized U.S. citizens, not those who were born in the United States. More specifically, this is an ordinal variable where the attributes are not only different but also ranked, where categories represent differences in ranks. A U.S. citizen, for example, is higher than an LPR as an immigration status because it allows people to have more rights and privileges. Number of crimes is a ratio variable, a numerical variable, because it contains a theoretical true zero point. Its attributes are made of the number of offenses committed by each immigrant or participant in the sample. As you can probably imagine, that categorical variable immigration status is most often than not the predictor or the independent variable, and the number of crimes is the outcome or the dependent variable. A few things before we move on to statistical testing of the hypotheses. Significance testing is a statistical method used to determine if the results of an experiment or study are likely to be due to chance or if they reflect a true effect. In this process, a null hypothesis is tested against the alternative hypotheses. The key concept here is the p-value, which represents the probability of obtaining the observed results, or something more extreme if the null hypothesis is true. A low p-value, typically equal to or smaller than 0.05, indicates strong evidence against the null hypothesis, leading to its rejection in favor of the alternative hypothesis. This probability is an accepted threshold in social sciences research. There are two types of errors in hypothesis testing. Type 1 error, or alpha, occurs when the null hypothesis is incorrectly rejected when it is actually true. This is also known as a false positive or alpha error. The significance level alpha sets the probability of making a type 1 error, commonly set at 0.05. In our hypothesis about crime and immigration status, type 1 error would be if, in reality, there is no difference in crimes committed by people in different immigration status, but we conclude that there is. Type 2 error, or beta, occurs when the null hypothesis is not rejected when it is actually false. This is known as a false negative or beta error. The probability of making a type 2 error is denoted by beta, and the power of a test, 1 minus beta, reflects the probability of correctly rejecting a false null hypothesis. In our hypothesis, type 2 error would be if in reality there is a difference in crimes committed by people in different immigration statuses, but we conclude that there is not. Those errors would produce mistakes in policy changes if policy was implemented based on those findings. Balancing these errors is crucial in statistical testing. Reducing the risk of one type often increases the risk of the other, highlighting the importance of thoughtful experimental design and sample size selection. The units of analysis refer to the entities being studied and from which data is collected to test a hypothesis, and in this study would be immigrants and naturalized U.S. citizens. The sample is comprised of 150 participants, and again, it's completely made up in Excel. Let's keep in mind that the hypothesis we are testing here is fictional, although it would be very interesting to know this relationship. Data is created in Excel using the random function and then imported into SPSS, where a cleaning process occurred. Let me show you now the data and how this hypothesis is tested using SPSS. As you can see here on the screen, I have Excel and SPSS opened up. Excel is on the left side, SPSS on the right side. How did I create the data? I created two columns, number of offenses and immigration status. For immigration status, I created 4 different statuses, as you can see on the screen. And for the number of offenses that each one of these participants, each row is a participant, I created a random function, and Excel assigned a number from 0 to 5 in order to show us the number of offenses for each of these fictional participants. As you can see, there are 150 participants, and these offenses here show up as different numbers from the number of offenses in Excel, but this changes every time I hit enter because of the random function. Okay, so I created the data in Excel, imported into SPSS. SPSS doesn't look that much different from Excel. The immigration status, we know that is the independent variable, and the offenses is the ratio numerical variable, and that's the outcome. So we're going to test the significant difference between the number of offenses committed by different participants in different immigration statuses. I'm just going to go very quickly here to show you the statistical test, how this can be tested in SPSS. It happens that I know that ANOVA, or analysis of variance, is the test to be applied in this case. So we go to Analyze, the drop-down menu opens up, we go to Compare Means, and then we select One-Way ANOVA. In One-Way ANOVA, dialog box that shows up, let me bring it on the screen, I have the 2 variables in the data set. The dependent list is the dependent variable, or the outcome, and that's the number of offenses. I'm just going to grab and drag. I can use the arrow here. And the immigration status is the independent variable that goes into the factor field. Over here, very quickly, I'm going to go to Options. And in Options, I will select the descriptives. I want to know the mean number of offenses committed by each of the categories or the attributes in the immigration status. And I could go into more detail and get the homogeneity variance test or Welch's test, but I'm not going to do that. Know that I'm going to test it at a 0.05 alpha level or a confidence interval of 95%. I'm going to click continue. Everything is fine. I'm going to click OK, and I will bring the output window on the screen. And let me show you a couple of things. The first thing is the descriptive table gives you the mean number of offenses committed by each category. So it happens, again fictionally, that LPRs committed 2.24 offenses on average, and with the least number of crimes committed on average is by employment-based worker. Now all of these means here, refugees and asylees, 2.9 crimes committed on average. The mean for naturalized US citizen is almost 3. We see that there is a difference. For example, US citizens through naturalization committed more than the others, and employment-based workers committed less than the others. But are these differences significant? We go to ANOVA and we can look at only the significance. This is the p-value that we talked about before. This is smaller than 0.05, and if you remember, if the p-value is smaller than 0.05, we reject the null hypothesis. If you remember, the null hypothesis was that there is no significant difference between the number of crimes committed among the different immigration statuses. So we reject that. If we reject the no difference, then we accept the alternative hypothesis and we say that the evidence shows that there is a significant difference between the number of offenses committed by different immigration statuses. In this case, we can look at further at what kind of policy implementations we would encourage and recommend, but this is what we see. Sometimes you have to find the difference between only 2 groups, not 4 as we had here. I have created another data set where we now have only 2 groups. As you saw before, we had 4 different immigration statuses, and now we have only 2 immigration statuses. One is that there is non-citizens, and the other one is naturalized US citizens. What kind of statistical test is applicable to testing differences between 2 groups? That is a t-test. In this case, it's an independent samples t-test because non-US citizen and naturalized US citizen groups are independent of each other. I will show you very quickly how this is done. We go to Analyze, Compare Means, Independent Samples t-test. Let me bring this independent samples t-test dialog box over here. The number of offenses is the test variable or the outcome or the dependent variable, so we put that in there. Immigration status is non-US citizen or naturalized US citizen. We put it in the grouping variable. We can define groups by 1 and 2. Let's continue here and then click OK. The output will show the independent samples table. Now it's going to be a 2-sided p-value because selected a 2-tailed alternative hypothesis. So it's going to be a p-value of 0.276. All the intricacies of why I chose this p-value out of these 4 p-values are in the independent samples t-test video that I created, and you can find up there. So this p-value is greater than 0.05. Therefore, we cannot reject the null hypothesis. The null hypothesis in this case is retained. Therefore, we cannot state that there is a significant difference between the number of offenses committed by non-US citizens and naturalized US citizens. So I hope that the demonstration of the statistical tests made understanding hypotheses and variables a little bit easier. This concludes this video. Thank you for watching.